All right, today we're talking about Go. Now, you might not hear about it as much as, say, Python or JavaScript, but it has quietly become the absolute bedrock of the modern cloud. So, what's the big deal? Let's dive in and find out.
You know, anytime a new programming language pops up, the first question on every developer's mind is why? I mean, seriously, do we really need another one? What problem is this solving that we couldn't solve before? Well, for Go, the answer isn't just about code. It's about a huge, fundamental shift in how our computers actually work. Think about it. In just the last couple of decades, the hardware we use has gone through this insane revolution. We jumped from clunky single-core processors to these powerful multi-core beasts. We moved from servers in a closet to the massive distributed cloud. All of a sudden, our machines could do tons of things at the exact same time. But there was a catch, a big one. The programming languages most people were using, they were still thinking like it was the 90s.
And that ability, that magic of doing multiple things at once, that's what we call concurrency. It's something you experience every single day. Just think about using Google Drive. You kick off a huge file download, but you're not stuck, right? You can still browse your folders and rename files. That's concurrency. It's what makes modern apps feel so snappy and responsive.
Okay, so concurrency is awesome, but here's the rub. For a really long time, actually writing code to use all that new parallel power was, well, it was a nightmare. Sure, languages like C++ or Java could do it, but the code you had to write was unbelievably complex, super hard to debug, and just a breeding ground for nasty bugs. Everyone knew there had to be a better way.
And that's where Go strolls onto the scene. This all started back at Google, around 2007. Their engineers were facing these exact problems, but on a massive, Google-sized scale. They realized they needed something new, built from the ground up for this new world of multi-core processors and sprawling network systems. So Go's mission was crystal clear right from day one. This wasn't about creating just another language. Nope. This was a purpose-built tool with one primary goal, to make writing those tricky, concurrent apps easy. The whole idea was to let developers tap into the incredible power of modern hardware without pulling their hair out. Okay, so that's a pretty bold mission, right? How on earth did Go pull it off? What was its secret weapon? Well, the answer comes down to one game-changing feature, something called a Go routine. So think of traditional threads in other languages as being kind of heavy and expensive. You can't have too many before your system slows down. Go routines, on the other hand, are the complete opposite. They're incredibly lightweight. This means you can spin up thousands, even millions of them, without breaking a sweat. And the best part? To run a piece of code concurrently, a developer just types one simple keyword, Go. That's it. It's ridiculously simple. Now, as amazing as Go routines are, Go's appeal is about more than just concurrency. The engineers who designed it were really ambitious. They wanted to create a language that really gave developers the best of both worlds.
So, on one hand, you have high-level languages like Python, which are super simple and easy to read. On the other, you have low-level languages like C++, which are blazing fast, but can be pretty complex. What Go's designers did was brilliant. They cherry-picked the best parts of both. They took the simple, clean syntax from the Python world and fused it with the raw speed and efficiency of the C++ world.
And the hits just keep on coming. First off, Go compiles like crazy fast. Then it packs your entire application into one single file, just one. This makes deploying your app an absolute dream. On top of that, it sips resources, it's super light on CPU and RAM, and that clean syntax, it means that when you come back to your code 6 months later, you can actually understand what you wrote. A huge win for teams.
Okay, that all sounds great in theory, but where does the rubber meet the road? Where are you actually seeing Go out there in the wild?
Well, to put it simply, Go is pretty much the backbone of the modern cloud. Think about the most important foundational tools that basically run the internet today. I'm talking about giants like Docker, Kubernetes, HashiCorp's Vault. Guess what? They're all written in Go. And it's no accident. That perfect mix of speed, efficiency, and dead simple deployment makes it the absolute go-to language for building this kind of mission-critical infrastructure.
All right, I know what you might be thinking. Oh no, he's about to show us code. Don't worry, I just want to give you a quick peek under the hood so you can see for yourself what Go code actually looks like. You'll be surprised at how clean and simple it is.
Okay, let's break this down real quick. That first line, package main, just tells Go, hey, this is a program you can actually run. Then, import FMT, we're just pulling in a standard tool that lets us print stuff to the screen. Func main is the starting line, where Go knows to begin.
And finally, the action, fmt.println, does exactly what it looks like it does. It prints hello Go. See? No fluff, no ceremony, just a straight line from what you write to what you get. And this simplicity isn't an accident. It's the entire point. It gets to the core philosophy of Go. The designers intentionally left out a lot of complex features you find in other languages. The goal was always to create a language that was incredibly easy for anyone on a team to pick up, read, and maintain. So, if you had to boil it all down, Go's appeal really rests on three main things. First, you've got simplicity. It's just easy to learn and work with. Second, performance. It's wicked fast and efficient. And third, that killer feature, concurrency, which lets it handle all the parallel tasks of the modern world without breaking a sweat. Simplicity, performance, and concurrency. That's the magic combo.
Really, when you think about it, Go is a language that takes on the heavy lifting. It shoulders the burden of all that modern complexity so it can free up developers to focus on what they do best, building awesome software, not fighting with the nitty-gritty details of the hardware underneath.
And that really brings us to the big question, doesn't it? As our software world gets more and more distributed and the hunger for performance just keeps growing, is Go's approach the future? Is having simple, built-in concurrency not just a nice-to-have anymore, but the absolute key to unlocking the next wave of software? Something to think about.